Good morning. Welcome to
KidMath153.
KidMath153. So we're starting the section on absolute value in our book, and the first thing they did was define absolute value. And how is absolute value defined?
As the distance away from 0.
Okay, so as the distance away from 0. So for example, the absolute value of 3 is what?
Is 3.
It's 3. The absolute value of minus 2 is?
2.
2. It's 2 away from 0. Okay, and then their second example was a problem like this, so I've just made up a new one. Graph this equation, y equals the absolute value of 2x minus 4 minus 1. And this is a good little exercise just for playing around with absolute values. So how would you like to do this problem?
Well, first I'll check when x is 0, what do we get?
Okay.
So we get the absolute value of minus 4, which is 4, minus 1, which is 3.
Okay, so at x equals 0, this graph is 3. Okay, so we found 1 point on the graph.
When x is 1, we get 2 minus 4, which is minus 2.
Alright.
So that's going to be, so it's 2 minus 1, which is 1.
Okay, so when I plug in x equals 1 to the equation, I get 2 minus 4, which is minus 2. Find the absolute value, which is 2. Subtract 1, and I get 1. Okay, awesome.
When x is 3, we get 6 minus 4, which is 2 minus 1. 2 minus 1 is 1.
Okay, so when x equals 3...
But I forgot to check 2.
Yeah, poor little 2. 2 gets a sad face because you skipped it. Oh, you skipped me.
2 is the absolute value of 0 minus 1. So it's minus 1.
Okay, so sad face turns into 0.2 minus 1. Make it a big nose with a sad face.
So it's going to go, it seems like it's going to make this V shape, where it's 0 is at 2.
Okay, looks like it makes it, we're guessing it makes a V like that. Now, why does that at least look plausible?
Well, because the slope, it's steeper than 1. The slope's steeper than 1.
Okay.
And we thought it was going to be 2.
Alright, so it looks like we should have a slope of 2 since this absolute value looks like a line. The graph of absolute value of x is this V shape centered at 0 with slope 1 and slope minus 1. Looks like we have something here with a steeper slope than that, maybe 2 and minus 2. Okay, what else about this V shape that we got here helps you think that this could be the right graph?
Well, because of the minus 1, it shifts down 1.
Okay, so the lowest point on this graph is minus 1. And tell me why that makes sense.
Because you've got this equation, and you just had, whatever this y value is, you subtracted 1 from it.
Okay.
So you just shifted the points down 1.
Okay, but why minus 1? Why does that look like a reasonable guess for what the lowest value of that graph could be?
Because the lowest value is when this is 0.
Okay. Inside the absolute value, including the absolute value, can never be less than 0. So the absolute value of this, the lowest part of this is probably 0. Then subtract 1, you get minus 1. Okay. So there you go. I said intro to absolute value of x. I kind of skipped over the super basic intro, and we went to a relatively straightforward absolute value equation, and we see we get a v, and we can understand where the lowest point was. Now, there are absolute value equations that get much more complicated than this. You can imagine, like, something that had a couple of v's in it. Maybe it could get really tricky. So I think, well, I haven't even looked yet, but I bet we're going to get to stuff like that tomorrow. All right? All right. Good job, sweetie. So it actually looks like a pretty interesting section on special functions.